What if everything we knew about the beginning was wrong? Not just when the universe began, but whether it began at all. Deep beneath the mathematical surface of space-time, something strange is emerging. From the echoes of ancient light to the tangled loops of quantum gravity, a radical idea is gaining ground. The universe may be eternal. No Big Bang, no singular birth, no final death, just infinity. But if the universe never began, what does that say about us and our place inside it? Because forever is a terrifying thumbscribe. If you've ever looked up and wondered how it all began, or whether it ever did, join us as we chase the frontier where time itself might dissolve, to live inside, in the driest desert on earth, where rainfall is rarer than moonlight. An invisible voice from the beginning of time reaches us. Dr. Priya Katre, her hair tied back, eyes heavy with sleepless awe, peers into the glowing monitor at the Alma Observatory. She's looking not at stars, but before them. Not at galaxies, but at the fabric from which they were born. What she sees isn't wrong. It's to right, the cosmic microwave background, that omnipresent hiss of radiation left behind by the Big Bang appears, unsettlingly smooth, to uniform, to ordered, like paint spread evenly across a canvas, without a single brushstroke out of place. But the early universe was supposed to be chaotic, wasn't it? According to the standard model of cosmology, the universe burst into being around 13.8 billion years ago in an event known as the Big Bang, a moment of infinite density, infinite heat, and infinite mystery. Time, space, matter, all springing into existence in an instant. But what if that's not what happened? What if there was no beginning at all? This anomaly, this strange, excessive smoothness in the background radiation isn't just a glitch. It's a clue, a whisper from the universe itself, suggesting we've misunderstood our origin story. And Dr. Khatri isn't the only one listening around the world. Cosmologists and theorists have started to murmur, quietly at first, hesitantly, because the implications are seismic. If the data is accurate, and it increasingly seems to be, then we may be forced to abandon the idea that time has a starting line, that there was ever a moment when nothing became something. Instead, something even more unthinkable. The universe has always existed, and always will. No boundary, ... No beginning, just existence. But how do we even begin to imagine that? How can we picture something that was never created, that simply is? Let's pause and think. When we ask what came before the Big Bang, we hit a conceptual wall. Time itself is said to have begun there. But that's like saying a book started on page 1 and asking what happened on page 0. It feels nonsensical, and yet the evidence is building that page 0 may not exist, because the book never starts. The smoothness of the cosmic background implies that the universe was, at its earliest, already in an eerily balanced state, as though it had settled into a rhythm long before the opening curtain. Some theories suggest an eternal inflation, that our universe is just one bubble in an infinite foam. Others propose a bouncing cosmology, where universes collapse and rebound endlessly, like the inhale and exhale of a cosmic breath. But it all begins here, with a scientist in the desert, questioning the most sacred assumption of modern physics, that the universe began. And suddenly, that old comforting story, the universe sprang from nothing, expanded, cooled, formed stars, formed us, starts to feel like just that, a story. But what if that story isn't the beginning, but only the middle? What if the Big Bang was never a bang, but a transition? Human beings have always searched for beginnings. It gives us comfort, meaning, orientation. From the book of Genesis to the first stargazers, we've wanted an origin. But maybe the cosmos doesn't care for origin stories. Maybe it was never born. Maybe it simply was dot. And if that's true, if we are living in a universe with no birth and no death, then everything we thought we knew about time, space, and even meaning must be rewritten. So what does Dr. Khatri do with this data? She sends it to a colleague in Princeton, someone who's been quietly working on an alternative theory for years. A theory that doesn't require a beginning, only a change, but will come to him soon. For now, ask yourself this: if the universe never had a beginning, is this the aftershock of something we can't comprehend, or the silence between two infinite eternities? Paul Steinhardt has always felt like an outsider in the world of cosmology, not because he lacks credentials. Far from it. As one of the architects of inflation theory in the 1980s, he helped shape the very framework we use to understand the Big Bang. But now, decades later, he's turning away from that legacy, not because it failed, but because it worked too. Well, inflation theory posits that the universe underwent a brief, violent expansion immediately after the Big Bang, stretching space faster than the speed of light. It explains the uniformity of the cosmic background and the large-scale structure of the cosmos. It works mathematically. It fits the data. And yet, Steinhardt feels something's missing, because inflation doesn't explain why the universe began. It only tells us what happened after. So Steinhardt and his collaborator, Neil Torok, began exploring an older idea, something ancient, almost mythic in nature, that the universe is cyclic, that it didn't explode into being, but rhythmically bounces in and out of expansion, that the Big Bang wasn't a beginning, but a rebound. Imagine a heartbeat. Systole, diastole, contraction and expansion. The universe as a pulse, not one explosion, but an eternal rhythm. Every bang is followed by a crunch. Every beginning is simply the aftermath of an end. This is the essence of ekparotic theory from the Greek ekparosis, meaning conflagration or cosmic fire. It reimagines our Big Bang not as creation, but collision. A universe born, not from nothing, but from something else slamming into it. In Steinhardt's version, that something is another universe, or more precisely, another brain, short for membrane, floating in higher dimensional space. When brains collide, they create heat, energy, and space-time. The impact triggers a new cycle. But crucially, the bounce doesn't require a singularity. It avoids the impossible density problem altogether. Now ask yourself, if our universe is just one cycle in an eternal loop, where are we in that loop? Are we near the beginning of a new chapter or stumbling toward another collapse? And how many universes came before this one? 1,000, a billion. Can you imagine a cosmos where every you has already lived 1,000 times before, slightly different, slightly skewed, maybe even making different choices? We don't need a beginning, he says softly. We only need change. And that's the unsettling beauty of the model. It doesn't violate physics. It respects thermodynamics. And yet it destroys our most cherished comfort, that things begin and end, because in a cyclic cosmos, you were never born from nothing. You were shaped by echoes. The myth of the phoenix suddenly feels less like fantasy and more like physics. Death is not destruction. It's part of the loop, but here's the twist. This isn't just a poetic theory, it's testable. If the model is correct, then traces of previous cycles might still exist, like fingerprints pressed lightly into the fabric of space, subtle gravitational waves, deviations in cosmic temperature, entropy patterns that refuse to reset. And so, teams of researchers are now digging, not into the Earth, but into the deep sky, into microwave maps and tensor perturbations. They're looking for signs of an earlier heartbeat. And if they find one, it will mean the Big Bang wasn't a creation at all, but a collision we once thought time moved in one direction, like an arrow, sharp and forward. But if Steinhardt is right, time may be circular. The universe might be like a clock that ticks not forward into infinity, but around a dial, again and again. And in such a reality, finality becomes an illusion. Beginnings are just soft landings from a previous fall. Endings are just coiled springs, waiting to UN's pool. It's dizzying, isn't it? The idea that we might be trapped inside a loop so vast, we can't even see the curve. That everything we do has already happened and will happen again. But here's where the human element returns. Steinhardt isn't a mystic. He's a scientist who believes in logic, not law. And yet, even he admits that the implications are philosophically haunting. If the universe is eternal, if the past stretches infinitely behind us, then why now? Why this version of the loop? Why us? But, Professor, they ask, what came before the first bounce? Steinhardt smiles. Who said there was ever a first? In the world of theoretical physics, Carlo Rovelli is something of a poet. He speaks softly, with reverence, not just for math, but for mystery. And his work in loop quantum gravity might be one of the most radical attempts to explain the universe without ever invoking a beginning. Loop quantum gravity doesn't just challenge the Big Bang, it breaks apart the very fabric of space-time. According to Rovelli and his peers, space is not continuous. It's not smooth, like an endless sheet. It's granular, like pixels on a screen, but smaller, infinitely smaller. Down at the Planck scale, a billionth of a trillionth of a trillionth of a meter. Space is made of discrete loops, knotted, twisted, quantum threads of geometry and time. Time, in this model, is not a river. It's not even a flow. Time, says Rovelli, is emergent. It doesn't exist on its own. It only arises from change, from relationships between things. At the deepest level, time might be nothing more than a reflection of how things interact. And here's where the picture twists. If time isn't fundamental, then what does a beginning even mean? Loop quantum gravity suggests something astonishing. That before what we call the Big Bang, the universe contracted, shrinking not into a singularity, not into a point of infinite density, but into a minimum volume defined by quantum rules. A bounce point, a bottom to the curve, and then it rebounded. This is the big bounce, a moment of rebirth, not emergence, a soft reversal instead of a hard origin. And if that's true, it means the universe may have existed before the Big Bang. It had a past, a history, a different state of being, maybe even a different set of physical laws. Rovelli doesn't claim we can see this pre-bounce universe directly, but his models hint at subtle imprints, ghosts left behind, in the texture of cosmic background radiation, in gravitational wave patterns that ripple through space-time like aftershocks from a forgotten quake. But here's where things get even stranger. If time is not a fundamental property of the universe, then what we call before and after may not exist at all, not in any absolute sense. Events may be connected, but not sequenced. The past may be nothing more than a story our brains tell to organize chaos. And in that model, multiple versions of the universe might be playing out simultaneously. Ghost universes, not in space, but in state. Imagine a cosmic accordion. The universe compresses, expands, and at each bounce diverges into slightly different possibilities. A branching loop, a memory of itself, but altered. What would it be like to live in one of those shadow universes? Would the laws of physics feel the same? Would time run forward or sideways? These aren't science fiction fantasies. They're serious questions. At the bleeding edge of quantum cosmology, and though we don't yet have the tools to fully test loop quantum gravity, researchers are pushing forward, using numerical simulations, smashing particles, listening to the faint rumble of space. In Germany, at the Max Planck Institute, teams are now working to simulate quantum spacetime directly, attempting to model how the bounce might occur, and what residue it might leave behind. What they hope to find isn't proof of a beginning, but evidence of structure without origin. For Ravelli, this isn't just physics, it's philosophy. If there was no beginning, then the question becomes, not how did we get here, but why do we think we started? Is it because human minds crave order? Is it because we were born, so we assume everything else must be too? But what if the universe is more like a story with no first page, just chapters, spiraling endlessly through time, each one echoing the last, but never quite the same? What if you're living inside one of those loops right now, and have lived inside it before? The universe does not remember how it began, because it never had to. For decades, we were told the universe began with a singularity, a point of infinite density, where all of space and time were compressed into a single, unimaginably small dot. The Big Bang, the beginning of everything. But there's a problem. Singularities don't make sense. They're not objects, they're breakdowns. Failures, there where the math screams, I don't know what happens next. When Einstein's general relativity is taken to its limit, when gravity becomes infinitely strong, and space shrinks to zero, the equations no longer work. They divide by zero. They hit the wall. And that wall is what we've called the beginning. But what if it's not the beginning? What if it's just the limit of what we currently understand? In the 1980s, a brilliant and enigmatic mind began to question the entire premise. Stephen Hawking, confined to a wheelchair, but roaming across space-time in thought, proposed an idea so bold, so counterintuitive, that even some physicists called it poetic nonsense. It was called the no-boundary proposal. Imagine the universe not as a line, with a sharp starting point, but as a curved surface, like the Earth. You can travel around the globe endlessly, but you'll never find an edge. There's no first point on Earth's surface, only curvature. Now imagine time like that. Curved, finite, but unbounded. In Hawking's model, the universe doesn't emerge from a singularity. It emerges from a smooth, rounded geometry where time behaves like space, near what we call the beginning. Time may have morphed, changed, identity, becoming more spatial than temporal. If time didn't exist at the very start, then asking what happened before the Big Bang becomes meaningless, like asking what's north of the North Pole. Hawking wasn't alone. Collaborators like James Hartle and later Thomas Hertog, worked to refine the model. They used the language of quantum cosmology to explore how a timeless quantum foam could blossom into space-time, not through an explosion, but through a kind of cosmic unfolding. And here's the twist. It's not just theory. There are models derived from the no-boundary condition that align beautifully with cosmic observations. They predict a smooth, nearly flat, early universe, just like we see in the microwave background. No chaotic singularity, just a soft beginning. That wasn't a beginning at all. But if singularities aren't real, if they're just the result of pushing our math past its limits, then how many other truths in cosmology are mirages? What if we're looking for something that doesn't exist because we need it to exist? We crave beginnings, in stories, in life, in everything. But maybe the universe doesn't care about narrative structure. Maybe the cosmos just is, unfolding in ways our brains were never built to fully grasp, and still. Physicists keep hunting at CERN. Particle collisions push matter to energies that mimic the first trillionths of a second after the Big Bang. At LIGO and Virgo, gravitational wave observatories strain to catch echoes of the universe's first breath. And at the Planck mission, cosmologists scan the sky for patterns, tiny fluctuations that might hint at what happened before. And yet, the singularity remains missing. Or perhaps was never there at all. Singularities are like that. Not destinations, but signals. Warnings that we need a deeper theory. One that unites the two great pillars of physics, general relativity and quantum mechanics. Because right now, they don't agree. Einstein's smooth curves of space-time and the jittery probabilities of quantum fields clash violently at the supposed beginning. What we need is a quantum theory of gravity, something that can describe space-time at its smallest scales. And until we have it, singularities will continue to haunt our equations. Not because they are real, but because they are gaps in our understanding. So maybe the universe didn't begin with a bang. Maybe it didn't begin at all. And if that's true, then time itself may not be what we think it is. It may not flow. It may not even be real. But if time isn't real, what is memory? What is change? What is now? At the South Pole, a telescope called BICEP stands against the cold silence of deep time. Its mission, to detect ripples in space-time, gravitational waves from the earliest moments of the universe. These waves, if found, would confirm a key prediction of inflation theory, the smoking gun of the Big Bang dot. And in 2014, they found something, a signal, a pattern in the polarization of the cosmic microwave background, whispers from just trillionths of a second after the supposed beginning. The news spread like fire through the scientific world, but celebration soon gave way to caution. When the data was cross-checked with readings from the European Space Agency's Planck satellite, something didn't add up. The signal BICEP to detect it, once thought to be a gravitational wave, was largely explained by interstellar dust. But here's the twist. Even after accounting for the dust, anomalies remained. Small, persistent irregularities in the CMB temperature fluctuations, alignments, cold spots, things that standard inflation theory couldn't fully explain. In particular, one cold region, the so-called cold spot, stood out. It spans over 1.8 billion light-years and appears to be cooler than surrounding areas by hundreds of Kelvin. A statistical fluke, perhaps, but some researchers wondered, could this be an imprint from something before the Big Bang? One of those researchers is Laura Massini-Horton, a physicist who proposed a bold idea. The cold spot, might be the scar left by another universe, a ghostly collision echoing across our own. In this model, our universe is just one of many, birthed in a multiverse, a cosmic foam of endlessly inflating domains. Sometimes these domains collide, and when they do, the impact leaves a mark, not a crater, but a distortion in the fabric of space-time, like bruises beneath the skin of the cosmos. The cold spot might be one such bruise, an echo from a sibling universe, a message in the pattern of ancient light. But how do we test that? Back in Paris, teams working with the Planck data begin to dig deeper. They search for hemispherical asymmetry, directional biases in the CMB. That shouldn't exist if the universe is perfectly homogeneous, and they find them. Not proof, but puzzle pieces, clues like fingerprints left at the scene of a cosmic crime. These echoes don't scream, they whisper, but their consistency suggests something profound, that our universe may have memory, not of events within it, but of events outside it, before it, and this changes everything. Because if the cold spot is real, if it's not just chance or statistical noise, then we have our first tangible hint that the universe's history extends beyond the Big Bang, that the fabric of reality was already stitched with information before time, as we know it, began. And here's the philosophical twist. If evidence of a previous universe can survive our entire cosmological history, then what might we leave behind for the next one? What echoes are we creating? In Hawaii, atop Mauna Kea, the Subaru telescope scans the sky in infrared. It's part of a global effort to find anomalies, not just in the background radiation, but in the structure of galaxy distributions themselves. Some patterns appear off, clumped, or aligned with axes they shouldn't be. Researchers wonder aloud, could this be directionality inherited from a prior universe? In physics, that's called conservation of angular momentum. Could the universe itself carry spin from a parent cosmos? Could we be rotating on an axis we can't see, from a time we can't remember? It's not provable, not yet, but the search has begun. And if the data leads where it's beginning to point, we may have to confront a mind-bending idea that the Big Bang was not an explosion, but a collision. That our universe is not a lone miracle, but a ripple in an eternal sea. An echo from what? We still don't know, but we're listening. What if our universe isn't alone? Not metaphorically, literally. Welcome to the world of brains, short for membranes, where string theory collides with higher dimensional reality, and the Big Bang is no longer the birth of time, but the aftermath of an impact. String theory was born out of the attempt to unify all fundamental forces into one grand equation. But as the math matured, it hinted at something stranger. Our familiar 3 dimensions of space and one of time might be just a slice of a much larger structure, a 10 or 11-dimensional reality we can't see. Inside this expanded cosmos, known as M-theory, exist brains, vast, multidimensional objects. Some stretch infinitely, others fold, some are paper thin, and one of them might be us. Our entire universe, galaxies, stars, your memories. This sentence could be confined to a 3-dimensional brain floating in a higher dimensional space, known as the bulk. This is the heart of the ekpyrotic universe, a model inspired by M-theory, refined by physicists like Justin Cowrie and Paul Steinhardt. It proposes that our Big Bang wasn't an origin, but a collision between 2 brains. Imagine 2 colossal sheets in an invisible void. They drift, they ripple, and then impact. The energy of the collision releases heat, motion, matter, space, and time erupt outward. A universe is born. But here's the twist. Those brains don't stop. They move. Away, then return. Crash again. Another bang. Another universe. A cycle not of nothingness, but of impact. Dr. Lisa Randall helped bring these models into the mainstream. She showed how extra dimensions could be warped, curved so tightly we can't perceive them, even though they shape our reality in one of her most famous models. The Randall-Sundrum scenario. Gravity leaks into other dimensions. That might explain why gravity feels so weak compared to other forces, because it's being shared across brains. But what if more than gravity leaks? What if entire histories can be transferred? Some theorists propose that during a brain collision, information might pass from one universe to another, like echoes through a wall. The structure of physics in our cosmos, the strength of gravity, the speed of light, the masses of particles, might all be inherited from previous cycles. In this view, the laws of nature aren't written at the moment of the bang. They're passed down like genetic memory, and that raises a haunting question. What universe came before us? What kind of reality gave rise to this one? The idea of brain collisions offers something even more unsettling. We may not be alone right now. There could be other brains, other universes, drifting alongside us in the bulk, invisible, untouchable, but real, and someday, perhaps in trillions of years. Another collision, the next bang. Everything we know, extinguished in a flash, and reborn again. Cycles are not foreign to nature. Seasons, tides, orbits, death, and rebirth. Even civilizations rise and fall in echoes. Why not the universe? In this model, there's no ultimate beginning, no divine ignition, just motion, contact, collision, the rhythm of existence. But we still don't know what lies in the bulk. We can't touch it, can't see it. We only feel its influence like shadows under a locked door. And here's where things turn philosophical. If our universe is one brain among many, what defines reality? Is it confined to our membrane, or does it stretch across dimensions? We'll never reach, and if a collision gave birth to us, does that make the next universe our descendant? Are we ancestors of a cosmos that doesn't yet exist? Experiments at CERN and Fermilab continue to search for clues. Microscopic black holes, graviton leakage, dimensional asymmetries. If even a single particle deviates from expected behavior, it could point to extra dimensions. And if they find it, then brain theory doesn't just become viable. It becomes real. And the Big Bang becomes a bruise in a larger story. In every moment, something irreversible happens. A drop of ink disperses in water. A fire burns to ash. A memory fades. Entropy increases. It's one of the few absolute rules of the universe. The second law of thermodynamics. In any closed system, disorder or entropy tends to rise. And that law gives us something more precious than even light. It gives us time's direction. We know we're moving forward because things become messier. But here's the paradox. If the universe has always existed, no beginning, no first moment, then why does it appear so orderly at the start? Why is the early universe smooth, balanced, and low in entropy, when according to logic, it should be a chaotic mess? That ordered deck, that low entropy beginning, is our universe. It contradicts everything we know about probability. It's like shattering a glass and watching it reassemble itself. The odds are astronomical. So, why did it happen? This question has haunted physicists for decades. And among them is Sean Carroll, a cosmologist known not just for his clarity, but his willingness to embrace the strange. Carroll doesn't deny the second law, but he asks a deeper question. What if the arrow of time is not a universal truth, but a local illusion? What if entropy isn't always increasing everywhere? In 2004, Carroll and his collaborator, Jennifer Chen, proposed a model that shook the foundations of time. They suggested that, in a truly eternal universe, the lowest entropy state is not at some distant, unreachable beginning. It's the middle. Imagine a timeline stretching infinitely in both directions. At its center is a rare low-entropy event, a fluctuation. From that center, entropy increases in both directions. One direction becomes our past, the other, someone else's future. In that picture, we are on one slope of the mountain, but on the other side, time might flow backwards. There could be another universe, a mirror cosmos, where people age in reverse, where cause follows, effect in a direction alien to our perception. And here's the twist. From their perspective, we are the ones moving backward. But is this just metaphysical gymnastics, or could it be real? Let's zoom in quantum mechanics. The laws of physics are mostly time-symmetric. They work the same whether you play them forward or backward. Entropy, and our perception of time, is the only thing pushing a preferred direction, which raises a terrifying question. If entropy defines time, then is time real, or just a consequence of statistics? Back in Los Angeles, Sean Carroll sits in his office at Caltech. Books spill off the shelves. His cat naps in the corner. He explains the entropy problem, not with equations, but with metaphors. Time, he says, is just how we experience the universe unraveling. But in an eternal universe, where no beginning anchors the structure, that unraveling could happen infinitely often on either side of the cosmic timeline, and entropy would never reset, just fluctuate, spontaneously, randomly, like waves in an endless sea. So here's the philosophical gut punch. If our entire observable universe is just a statistical fluctuation, a low-entropy bubble in an eternal chaos, then everything we know, everything we are, might be the exception, a temporary, improbable miracle. And when it ends, when our entropy catches up, we dissolve into equilibrium, forgotten, unwritten. But there's one more theory, a bold, chilling idea. What if entropy doesn't just increase? What if it reverses in other pockets of the cosmos? Some cosmologists imagine universes budding off like soap bubbles. Each begins with a fluctuation, and each forms its own arrow of time. Some forward, some backward, some sideways. In one such universe, you are being born right now, backwards. Your life is a rewind. You end at the start. Could that person that reversed you be wondering the same thing? So, where does that leave us? The second law still holds. Entropy still rises here, now. But in the grandest scheme, across all possible realities, time might not point in any direction at all. It might not point at all, it just is. For millennia, humans wondered what reality is made of: stone, fire, atoms, fields. But in the 21st century, a new answer emerges. Information. The fundamental units of existence might not be particles, but bits. Yes or no, on or off. If reality is information, can it be simulated? And if it can, are we already inside a simulation? It sounds like science fiction. Yet today, researchers are building digital universes from scratch, not on a godly scale, but within the metal and silicon of modern supercomputers. Their goal, to understand how universes, with no beginning and no end, might actually behave. Alyssa Reynolds isn't alone. Around the globe, at places like CERN, Fermilab, and Google's Quantum AI Lab, teams race to model the birth and death, or non-birth and non-death, of digital cosmoses. In these simulations, there's no Big Bang, no singular moment of creation. Instead, the digital universe simply is, an infinite fractal, existing at every scale, in every direction. It grows and shrinks, folds and unfurls, cycles forever, or never cycles at all. But why simulate an eternal universe? Why not just stick to the observable? Because in these digital labs, the laws of physics are malleable, constants can be tweaked, time can be made to loop, branch, or dissolve. The hope is that by running enough versions with enough tweaks, patterns will emerge. Clues to why our universe feels like it does. In one simulation, time is circular. Events repeat endlessly, but with tiny quantum differences, like ripples in a pond that never quite overlap. In another, time doesn't exist, just a web of cause and effect, every possibility happening at once. And in a third, digital entropy flows both ways, order rising and falling in endless, unpredictable tides. And here's where things get unsettling. The more complex the simulation, the more it becomes impossible to distinguish from reality, patterns of emergent behavior, stars, chemistry, even digital life begin to arise. Sometimes, the simulation even surprises its creators, revealing rules and structures no human ever programmed. Some philosophers and scientists, like Nick Bostrom, take this to a chilling conclusion. If simulated universes can become complex enough to produce intelligence, and if there are potentially infinite simulated universes, then the odds we are living in the real original universe become vanishingly small. We might be living inside someone else's simulation, someone else's eternity. Are we lines of code in a cosmic mainframe, running a story that never truly began? Alyssa Reynolds isn't trying to create consciousness, but she watches as her simulation ages. Galaxies burn, then cool, then merge, then spark again. Patterns emerge, accidents, surprises, a digital eternity written in code. How would I even know if I were inside a simulation? Viewer, what would you do if you discovered that your memories, your world, your very sense of time were written in an algorithm, endlessly looping? Would it change the way you live? Or would you simply keep moving forward, writing your own pattern in the code? The hunt isn't just for novelty, it's for truth. If one simulation matches the patterns we see in our own universe, it could hint that reality itself is information, that eternity is possible, even natural, but the digital eternity raises its own paradox. If we can build simulated universes, and they, in turn, can build universes inside themselves, then where does it end? Or does it ever end? An infinite recursion. Simulations within simulations, each unaware of the one above, each believing it is real, a cosmic hall of mirrors. So are we the first dreamers, or the dream of a dream. And if we can create digital eternities, does that make us gods, or prisoners, black holes? They are the universe's most brutal editors, swallowing stars and light, erasing everything in their path. Yet, paradoxically, it's at the edge of these cosmic abysses, the event horizon, that some of the most radical ideas about eternity are born. It was here, in the early 1990s, that theoretical physicist Leonard Susskind confronted a cosmic riddle. According to Stephen Hawking's calculations, information falling into a black hole was lost forever, violating a fundamental law of quantum mechanics, that information cannot be destroyed. But Susskind refused to accept oblivion, so he dreamed up something stranger than fiction: the holographic principle. Imagine you walk into a theater. The actors, props, and action appear three-dimensional, but the movie is just light projected onto a flat screen. What if the universe is the same? What if everything we see, feel, and experience in 3 dimensions is actually painted onto a 2-dimensional surface at the boundary of reality? In this vision, our entire cosmos, galaxies, planets, people, memories might be a hologram. The true information encoded on a distant surface we can never reach. Here's where things turn uncanny. At CERN, in Switzerland, teams working on the Large Hadron Collider search for evidence of extra dimensions and the quantum pixels that might make up reality's surface. No one has found definitive proof, but hints appear in the math of string theory, in patterns of black hole entropy, and in how information seems to be stored at the edge of space. The holographic principle isn't just poetic, it solves problems. In a holographic universe, black holes don't erase information. Instead, everything that falls in is smeared across the horizon, like ink on paper. Nothing is lost. Everything is preserved. So, what does this mean for beginnings and endings? If the universe is a hologram, then what we call the beginning, the Big Bang, might be a kind of projection, a mirage on a cosmic screen. No edge, no singularity, just encoded information, unrolling its story for us to experience. But can we ever test this? Maybe at Fermilab. Physicist Craig Hogan leads an experiment called the holometer, trying to detect the pixelation of space itself. If reality has a finite resolution, like a screen, tiny jitters, Planck scale blurs should show up in sensitive detectors. So far, results are tantalizing but inconclusive. Meanwhile, theorists probe the boundaries of mathematics and philosophy. If space is just a projection, then so is distance. If time is just information, then so is memory. What does it mean to be real if reality is just a shadow on a higher dimensional wall? Here's a wild implication. If information is fundamental, the universe is digital at its core, maybe eternity is a property of information, not matter. Just as a film reel can be rewound, paused, or looped, perhaps the universe can as well. Maybe we are experiencing one version of a story written on the surface of reality. Maybe there are other versions, rewound, fast-forwarded, paused, at different scenes. Are we just one playback in an infinite library? Back at CERN, physicists collaborate across cultures and continents, united by a single goal: to find the hidden code. They hunt for quantum gravity's signature subtle fingerprints in the noise. If they find it, if the holographic principle is proven true, then every moment, every beginning and end becomes an illusion. There never was a first frame. There never will be a last dot. Just information, always encoded, forever preserved no matter what happens to the matter itself. So, if the universe is a hologram, what are we? Projections, or the encoded dreamer behind the screen? We experience time as a river, flowing from past to present to future, carrying us onward whether we wish it or not. But deep within the equations of quantum mechanics, a stranger truth emerges: time, as we know it, may not exist at all. For most of physics, time is just another dimension. In Einstein's relativity, it bends, slows, stretches. But in the quantum world, time is not even required. The mathematics that govern the smallest particles are timeless. The famous Schrödinger equation, the bedrock of quantum theory, contains no arrow of time. Events can be calculated forward or backward, and the rules remain the same. So why do we feel the relentless push from past to future? Julian Barber, physicist and philosopher, thinks we're asking the wrong question. In his radical vision, reality is a vast collection of now's discrete moments, scattered across the landscape of possibility. The illusion of time arises, not from movement, but from memory, each now containing traces of the one before. Imagine the universe as a cosmic flipbook, each page a separate, complete world, stars, planets, people. When we move from one page to the next, we experience the illusion of passage, of time. But all the pages past, present, future exist equally, eternally. Nothing actually moves. Only our consciousness skips through the sequence. It's unsettling, isn't it? To think that everything you've ever done, every decision, every joy and sorrow, already exists somewhere in this infinite library of moments. But Barber's idea finds strange support in quantum cosmology, the Wheeler-DeWitt equation, meant to unite quantum theory with gravity, is also timeless. It describes the universe as a static wave function, a block universe, where all events are fixed, and the flow of time is a perceptual trick. If this is true, then beginnings and endings are illusions. There was never a true before, no final after, only the endless presence of now. Some physicists find this horrifying. If nothing really happens, what is the point of existence? But Barber finds beauty in it. Every moment, he says, shines with its own light. Nothing fades. Nothing is ever truly lost. Yet even in a timeless universe, we crave meaning. We tell stories, invent causes and effects, remember and hope. Why? Because our brains are built to string nows, together creating continuity out of chaos. It's a survival skill, a necessity for life. But deep down, reality might not care about our need for order. Quantum mechanics leaves room for strangeness. Particles can exist in superpositions, here and there, then and now. When we measure them, possibilities collapse into a single outcome. A new now. Is the universe constantly choosing which now to become? Or do all possibilities coexist, forever frozen in the quantum web? The search for time's foundation leads scientists to the edges of philosophy and science fiction. Could consciousness itself be a journey across nows? If so, then maybe we are travelers in eternity, never moving, only awakening from one now. To the next viewer, how would your life change if you knew this moment, this exact now, would exist forever? Would you cherish it more, fear it less? If every now is eternal, does that make loss impossible, or simply make meaning more precious? Physicists at institutions like the Perimeter Institute and Oxford continue the hunt for time's secret. Some use quantum computers to simulate timeless universes, searching for patterns. Others probe the heart of black holes, where time seems to stand still. But for now, the mystery endures. Perhaps time is an illusion so powerful that even the universe believes it. In the ancient world, mathematics was magic. Priests and philosophers alike believed numbers were woven into the bones of reality. Today, We may have more equations than incantations, but the awe has only deepened. In our quest to understand a universe without beginning or end, math isn't just a tool, it's the territory. Consider this. Every law of physics can be written as math. Gravity, quantum fields, even entropy. We use symbols to describe everything from black holes to the flutter of a hummingbird's wing. But sometimes, the math writes back. Enter causal set theory, radical new approach that challenges the very idea of space-time. Pioneered by physicists like Raphael Sorkin, causal set theory suggests that reality is not a smooth fabric but a vast interwoven web of discrete events. Imagine a universe built not from continuous points, but from countless dots connected by the arrow of causality. What happens, what follows, in this view? Time and space are emergent properties, like a tapestry woven from threads of cause and effect. There is no first event, no single start. The web simply is, stretching infinitely in every direction. Each event a node in the grand mosaic of existence. But the strangeness doesn't end there. In the last decade, artificial intelligence has entered the game. At DeepMind in London and Google's brain division, machine learning algorithms now hunt for patterns in data too vast and complex for any human to see. They've started to uncover new mathematical structures, hidden symmetries, surprising relationships that hint at laws of nature we haven't even imagined. One neural net, trained on billions of particle collisions, predicted results that later experiments confirmed before the human theorists understood the math. Another found shortcuts to quantum field calculations, revealing connections across physical theories that no one had spotted before. Are we on the verge of a new kind of science, one where math itself evolves, outpacing our ability to comprehend it? It's both thrilling and unnerving. If machines can uncover laws of reality, will we still understand what it means? Or will we become explorers in a world we can no longer explain? Dr. Maya Lee faces that very question. One night, her algorithm produces a result she can't pass. The equation describes a universe with no initial conditioner, reality that simply exists, bound by relations but not by time. She sits back, heart pounding. What does it mean to find a law that describes everything, yet has no origin? Perhaps, as mathematician Max Tegmark suggests, the universe itself is a mathematical structure, not described by math made of it. Every object, every mind, every memory is a solution to a vast, eternal equation. But here's the twist. If reality is math, then what determines the rules? Who or what writes the axioms? Are there universes where 2 plus 2 does not equal 4? Where time bends, splits, or never begins? At Oxford, mathematician Roger Penrose muses on Platonic realms, places where mathematical truths exist independent of physical reality. Could there be other realities, eternal, infinite living, as pure math, waiting for a mind, or perhaps a machine, to discover them? And what about us? Are we expressions in the equation, or the solvers? As AI and mathematics push deeper, old boundaries collapse. Science becomes philosophy, math becomes destiny. Perhaps the greatest proof the universe never began or will ever end is that its story can be written without a page one. Only relations and patterns, stretching forever. What if time is not the master of the universe, but its servant? What if time itself can be bent, erased, or even reversed subject to the whims of deeper, stranger laws? Inside this building, Physicists are not only questioning what time is, they're actively reprogramming it. Their weapon, quantum entanglement, is one of the most mind-bending features of quantum mechanics. Two particles become linked so completely that measuring one instantly affects the other, even across vast distances. But recent experiments go further. Dr. Salim and her team have entangled particles in ways that appear to send information not just across space, but across time itself. It's as if the future can reach back and touch the past. Some call this quantum retrocausality. It sounds impossible, even heretical, but the math holds. In one experiment, a measurement made in the present determines the state of a particle in the past. The timeline is no longer a one-way street, it's a tangled web. If this is true, the implications are staggering. Time may not be a fundamental ingredient of the universe at all. It could be emergent, like temperature, something that only makes sense when enough particles, enough nows, come together. And if time can be bent, perhaps it never began, but the death of time is not just a quantum phenomenon. At the cosmic scale, astronomers have found objects, black holes, neutron stars, the very fabric of space-time itself, where time behaves in ways that defy intuition. Inside a black hole, for example, time slows and finally stops. To an outside observer, nothing ever crosses the event horizon. To the falling object, time ends, so which is real? Is time a property of the observer or of the universe itself? Dr. Salim's team collaborates with theorists around the globe. At the Max Planck Institute in Germany, new models suggest that time might arise only for conscious beings, creatures capable of memory. To a rock, to a photon, time means nothing. For humans, it is everything. If time is a biological illusion, what does it mean for the universe to begin? Did we simply invent a starting line to make sense of our own existence? The experiments grow ever more ambitious. Quantum computers are tasked with simulating timeless worlds, universes where cause and effect blur into loops. Sometimes, these simulations show systems reaching stable states with no trace of time at all. Order from chaos, without any tick or tock. Here's the twist. If the universe never began, and if time is an emergent property, then maybe the most fundamental truth is change itself. Not a flowing river, but an endless ocean, waves rising, falling, blending, but never starting or stopping. She wonders aloud, if time is just a story our minds tell, then what are we? Characters in a plot, or fragments of a greater pattern? Viewer, what do you think? If you could step outside of time even for an instant, what would you do with your eternity? Would you go back, race forward, or simply stand in awe of the now, knowing it might be all there is? So the next time you check your watch or count the seconds, remember, time might be nothing more than the pulse of your own awareness, a fleeting dream dissolving as the universe breathes, without beginning, without end. Long before telescopes and equations, humans gazed upward and saw eternity. The Hindu Vedas speak of kalpas, cosmic cycles so vast that the rise and fall of universes are but breaths in the body of Vishnu. In Buddhist cosmology, time is a circle. Universes arise, flourish, collapse, and are born again in an endless wheel of becoming. The Greeks, too, imagined time as cyclical. Empedocles described worlds formed and dissolved by love and strife, eternally repeating. Even Plato spoke of the great year, when the heavens reset to their starting point, and yet, in every age, there were those who believed in a beginning. The Abrahamic religions envisioned a divine spark, a moment when light split from darkness, Genesis, and creation ex nihilo, which is truer. The universe as a story with a first page, or an endless epic with no beginning and no end. Neat thought experiment is more than a riddle, it's a challenge. Could you embrace your life every sorrow and every joy if you knew it would replay infinitely? Is eternity liberation or a prison? But even as philosophy asks, science listens in the early 20th century. Cosmologist Alexander Friedman and later Georges Lemaitre shaped the idea of the expanding universe, the Big Bang, as a moment of creation, yet the ancient whispers never faded. Modern physics, as we've seen, circles back to old stories. Quantum cosmology, loop gravity, brain theory all echo the same possibility that the universe may be timeless, or endless, or both. At Oxford, philosopher Nick Bostrom flips the question yet again. He proposes the simulation hypothesis. If reality can be simulated, then simulated universes may outnumber real ones. In such a world, beginnings and endings become artifacts, lines of code, set arbitrarily by unseen designers. Infinity, once the domain of poets and mystics, now belongs to programmers, too. But what does this mean for us? If eternity is real, there was never nothing then what of meaning, purpose, and hope. Some traditions find solace in the wheel, the idea that life, death, and rebirth are stages in a journey. Others, like Nietzsche, wrestle with despair as endless repetition, strip life of significance, or magnify its importance. Even in science, the debate continues. At the Perimeter Institute, Dr. Amira Salam muses with her colleagues over tea. If the universe never began, what are we? She asks, artifacts of the eternal, or flashes in the infinite dark? A student responds, quoting the Upanishads, "You are that which observes eternity." This longing to find ourselves in the vastness has never left humanity. The first astronomers measured cycles in the stars, seeking signs and seasons, searching for where it all began. The last astronauts, looking back at Earth, saw a blue dot floating in endless blackhand, felt both lost and found. In our bones, we crave stories. We want to know, why are we here? What came before us? But the cosmos may answer only with silence, or with endless echoes. So, viewer, what do you believe? Is infinity a comfort or a curse? If you knew your story was one strand in an eternal braid, would you live it differently? Comment your thoughts below. Your answer may be as old as the stars, and as new as tomorrow. After years of searching for a cosmic beginning, Dr. Khatri finds herself confronting a different kind of silence, not the hush before creation, but the endless, unfathomable quiet of eternity. Her team's latest data reveals no trace of an initial singularity, no sharp spike, no flash of creation, just a gradual fade, an echo stretching backward, older and older, dissolving into a haze with no boundary. The numbers are clear. The further they peer, the less the universe behaves as if it ever had a first frame. The microwave backgrounds, supposedly the baby picture of the cosmos, contains subtle fingerprints that don't fit the old narrative. The energy distribution is too smooth. The small anomalies, once dismissed as noise, now suggest a universe with no distinct starting gun. The implication is staggering. If there was no first frame, then the universe might be eternal, its story already in motion long before the beginning we once imagined. The classic picture of the Big Bang, a moment where everything erupted from nothing, may itself be a kind of mirage, an artifact of incomplete understanding? What does it mean to exist in a cosmos that was never truly born? The question ripples through the team. Some feel exhilarated. There is no beginning, there is no end, and discovery itself is infinite. Others are uneasy. If we were never created, only always here, does that change our meaning, our sense of purpose? One researcher, Dr. Marching, raises a soft question. If the universe never began, then our search for origins is just another echo. Maybe the cosmos isn't about beginnings or endings. Maybe it's about being. Their work triggers a cascade of analysis across the world. At CERN, theorists run new simulations universes that never start or stop, only shift. In Princeton, Paul Steinhardt revisits his cyclic models, now more plausible than ever. At the Perimeter Institute, Dr. Amira Salim considers the philosophical wait, if we've always existed in some form, is our story one of emergence or of revelation? For Dr. Khatri, the revelation is personal. She remembers her childhood sitting with her grandfather under the open sky, asking what was there before the stars. He answered, maybe there was always something. Now her data agrees, but what are the consequences for meaning, for life, for love? If you were never created but always woven into the infinite tapestry, are you less miraculous or more? The team debates late into the night. Is meaning a product of beginnings and endings, or of the endless web of connection? Is life precious because it is rare, or because it is eternal, one node in a network that can never be broken? In this new cosmology, existence is not a flash, but a flame burning without ignition, dimming without ever being extinguished. Viewer, pause for a moment. What would change for you if you knew you had always, in some way, existed? Would you feel lost or found? Would you cherish the present or fear its infinity? Science doesn't erase our questions, it only deepens them. With each discovery, the horizon retreats. We chase the beginning and find only more road. We long for the first frame, but there may never have been one. Only motion, only becoming. If the universe has no beginning and no end, what is it doing now? Is it expanding endlessly into darkness, or circling through cycles beyond our imagination? Is it still creating itself with every moment, or simply being unchanged, yet always becoming? The latest data from telescopes and satellites suggest an accelerating expansion. Galaxies speed away from each other, their light redshifting into oblivion. In 1 trillion years, the sky will go dark. Cosmic isolation, the ultimate horizon. But is this truly an ending, or only a pause before something new? Some cosmologists believe in a perpetual unfolding, an ever-inflating cosmos, bubbling with quantum fluctuations, spawning universe after universe, each with its own laws, stories, and possibilities. Others suspect cycles, universes dying and being reborn in bounces, collisions, or quiet dissolutions, like tides on an infinite shore. And then there are those who suspect we'll never know the whole truth, that infinity, by its nature, can never be fully grasped. We are finite minds in an infinite story. What does it mean to live in a forever unfolding universe? For Dr. Khatri, the question has become personal. She thinks of her grandfather's words under those childhood stars. Maybe there was always something. That echo stays with her, haunting and comforting at once. If existence never began, perhaps our lives are not accidental sparks, but threads in an endless tapestry, each moment a stitch that cannot be undone. Meaning, in this universe, isn't found in beginnings or endings. It's found in continuity, in what persists, in the stories we tell, the patterns we leave, the hopes we pass forward, even if nothing ever truly starts, and nothing ever truly finishes. For a universe with no beginning or end, hope is not a promise of rescue, it's a way of seeing, of making the infinite intimate, of standing before the endless and saying, I am here, I am part of this. Viewer, imagine, if you could exist forever, what would you make of your story? Would you repeat your choices, or seek the unfamiliar? If infinity were freedom, not confinement, how would you live now? The universe may have no original beginning to mourn, no end to fear, but that does not make our moments less precious. If anything, it means every instant matters more, because it is not just a fleeting frame, but part of a larger, unbreakable chain. The truth may be that we are each a ripple on the surface of eternity, moving, merging, transforming, and never truly disappearing. Existence is a conversation between what is, what was, and what will be. So, as we stand at the edge of forever, the only question left is the one we ask ourselves. Will we be paralyzed by infinity or inspired by it? We may never find the first frame or the final note, but as long as we search, hope, and wonder forever, from here is ours to write. If the universe never began, then maybe neither did the mystery. Comment your theory below. Is time real, or just our illusion? And if you've ever felt small staring at the stars, maybe that's the point. Share this journey, subscribe, and help us chase the silence between seconds where the truth might still be waiting.